Hi everyone, Randy back into CUA. I was just kind of wondering how accurate the frequency counter was on the RIGOL DSA-815, so remembering that I have at my disposal a oven controlled crystal oscillator running at 10 megahertz. It was supposed to be pretty darn accurate, so I figured let's connect that up to the RIGOL and see what happens. So right now we are reading a peak at, if you can read it on the screen, I'm not sure, but at 10.000000 megahertz at a minus 31.17 decibels. That's dBm actually, and that's pretty accurate, I'd say, just off the top. Now, some things that I had to do to get there, though, to get it to come up that accurately, because the signal coming out of the oscillator is a very narrow pulse. I had to make sure that the resolution bandwidth was as small as it could be, which is the lowest value, 100 hertz, and I had the video bandwidth also down to 100 hertz. And then I've adjusted the span to 13 kilohertz so that we can make as accurate a measurement as possible, and hence the 10.000000. I don't know if you can see these things on the screen here, but I was going to point out some stuff on the screen too. One thing I've been trying to do as I was doing different videos with the analyzer was to show you some of the features of the analyzer at the same time. So I wanted to do that for you. I wanted to go over the display a little bit. Again, it might be difficult to see, but at least you'll know where I'm pointing. The screen on the left here, there's a status bar, as it were, and it shows different settings, conditions, whatever that you have the analyzer set in. Like this one says peak, triggers free running, sweep is continuous. There's a correction factor one, I believe. Some for the other traces. There's a trace 1, trace 2, trace 3. A math function that you can perform on the traces, actually, which is a really nice feature. And then along the bottom, you have the center frequency, whatever that's set to. What the resolution bandwidth is set to, in this case 100 hertz. What the video bandwidth is set to, again 100 hertz. And over on this side of the screen, we have the span, which is the span of frequencies that it sweeps when it goes across, how wide that is. And then in the very bottom one, it has the sweep time, which in this case is 4.128 seconds. And then over on this side of the screen is your soft menu. As you press these keys here, different options come up, and you can select different things depending on what you want to do and what you're trying to measure and how you're trying to measure it. And up at the very top of the screen, there's a reference level setting which you set under amplitude, and it tells you what that's set to up here. And then also attenuator, which you've got the RF input attenuator set to. That value is listed here on the screen. Up in the very top in the center, you have the time and the date. I believe there's an option as to whether or not you want that displayed. And then right here is where, in my case, marker 1, which is the active marker, because you see over here, possibly, it says marker, select marker, and there's a possibility of 1 through 4 markers. And marker 1 is on, it's active, set to normal. And so it shows you that marker 1 is sitting at 10.000 megahertz at a minus 31.25 dBm. Now, one thing that'd be fun to do with this waveform, let's see, we're at 4 minutes here, so sometimes, and it's not really a thing you need to do with this one, but I just thought it'd be kind of fun. Down at the bottom we got the noise floor, and it's pretty noisy and everything, right? So you can clean a waveform up like this. If I can do this right, we'll hit the trace button and the trace type and do video averaging, and we'll just see if we can't clean up the noise, just out of curiosity. We'll see if the frequency changes when we do that too, because that would certainly be a bad thing if, when trying to video average, the frequency changes that you're measuring. Now I also believe that I have under sweep trigger, I have it set for accuracy. There's a normal and an accuracy, and I have it set for accuracy. It slows the sweep time down, but it gives you a more accurate indication, which is probably part of what would explain the resultant accuracy on our frequency measurement here of 10.6 zeros. Anyway, you notice now down at the bottom of the screen it's still sweeping, but it's cleaning up a lot of the noise because it's averaging it out. And eventually what that does is almost, put a single line across there, because noise is noise and it's random, and eventually the average of most of the noise will kind of cancel out, and it cleans up the waveform. It's really nice how it does that. Anyway, we're at about 6 minutes, so I just wanted to show that to everyone. I appreciate everyone watching and listening, and I'm enjoying making these videos, and I hope that I'll be able to make some more, and that there's some good useful information here for all you viewers out there. Thanks, have a nice day. 7-3 from N2CUA.